Problem number 1278, Palindrome Partitioning Part 3. Okay. So you're given a string S containing lowercase letters and an integer K. You need to first change some characters of S to other lowercase English letters. Then divide S into K non-empty disjoint substrings such that each substring is a palindrome, and return the minimum number of characters that you need to change to divide the string. Change some characters of S to other lowercase English letters, and divide S into K non-empty. What does it mean by disjoint substrings? It just means by partitioning the substring. So okay, so like you must partition the substring into K parts, and you can change some characters, whatever characters you want, and keep track of the number of characters you changed, and because we want to find the minimum number of the changing characters, and to make sure that every part of the string is a palindrome. Okay, yeah, so if it is already a palindrome, then you don't have to make any changes, so the minimum number will be 0. And yeah, if like example 3, like if you need to, like if the K equals the length of string, then like every part of the string is one letter, so it is a palindrome, then you don't have to change any characters, so you will return 0. Okay, and K will not be larger than the length of string. Okay, it makes sense. We will only have lowercase English letters. Okay. Yeah, I think I know what is going on, so we will move on to the solution. Okay, so for partitioning, like the brute force method will be iterate through every kind of partitioning ways, and calculate the minimum characters that need to change and find the minimum. So I will do it first with recursion, and then I think it will be a lot of calculation, like same calculation, so I will use like a catch or a matrix to memorize the same thing. Yeah, and yeah, let's see first. So I'll start with the last character. So if the last character SI is selected as a group, then so K will be -1, like K partition, like partition that needs to form will become K -1, and then the problem will become strings 2. So try to find the try to add up the characters that you need to change in the rest of the array. The problem shrinks to as a substring S 0 to SI. If SI is selected, count the number of characters to make a palindrome, and so for each partition we made, we need to count the numbers of we need to count how many characters should we change to form a palindrome, and then the problem will shrink to the rest of the subarray. We should find out how many characters we should change to form the rest of the array a palindrome. Okay, so then we have many kinds of partitioning ways. We can do select SI. We can select the last two elements. So if SI and S0, SI -1 and SI are selected, then we'll have the same thing, and the problem partitions, this will still become K -1 because there is only one group formed. The problem will shrink to SI -1. So it will be if SJ till I is selected, the problem shrinks to SI. SJ. Okay, then we can define, so I will first use a recursion and I'll call it the method DFS since it is like a depth first search. So it will be DFS. I will have K inside as a parameter as well, since this is a limitation. Okay, and so it will be defined as it will be like given like partition as 0 to si minus 1, so it's like separated as till I index I partition as into k to k parts that every part of the string is a palindrome. I'll say partition to separate into k parts, and find the minimum characters to change so that every part of the string is a palindrome. Yeah. Okay, then this will be this time complexity will be okay. If we don't count the palindrome part, then it will be an and multiplied by n. It's a k multiplied by n. Multiplied by, yeah, like you will have k parts to see, and then for each I there are n kinds of I, like n dense of string. Like you have si s0 to si substring, and you will also have s0 to si minus 1, so you will have and separate some strings. Then for each substring you'll have n kinds of partition ways. So yeah, it is like this, and we haven't counted the palindrome part yet, so I will say palindrome. Okay, so let's first start with defining the variable n as the length of string. And for DFS, we'll have k as a parameter, I as a parameter, and return int. For the boundaries, I will say if I is smaller, if I is smaller or equal than 0, like partition as the substring s till I. If this is 0, then no, then it is an empty string. Then then also there is that if k is smaller than 0, smaller or equal to 0, then we have nothing to partition. So there are two situations. So if like when k is already equal to 0, but we still have elements that did not partition, then it is an invalid case. That is an invalid case, so we will check. So if I is smaller or equal to 0, then this is empty, so we will return find the minimum characters. We will return 0, then else we will return if, since it wants to find the minimum characters. And if there are leftovers, it is not valid, so we'll just give it an inf. So this is the same. So if I is smaller, if we have an empty string, but our k is still larger than 0, that means we still have to have at least one partition, and it is invalid. So we'll have this. Then we'll move out for the boundaries. So if it's a normal case for j in range I, like j should not be larger or equal to I. So I'll have its upper bound to I. Then I'll first have we want to count the characters. So I'll say count equals 0. So it will have min count. We want min count between different partition ways. So count with this will be j, and plus palindrome count for, like we'll have another function that is the palindrome count, and it will have parameters like L and right. That is it will be L included but right excluded. Since we are selecting this as a group, so we will have palindrome count j and I. Then return count, and the answer will be started from DFS. And since we defined DFS, k is also this also have k minus 1. This is uppercase k. Since we defined as we define dfsi as the substring s0 to si minus 1. We have to include si, and that's dfsn. So yeah, and we will check or see how this can work for palindrome count. So given, I think like, yeah, if I want to make this, like if k is 1 and I want to make a, b, c as a palindrome, like, yeah, I will check the a, yeah, if a and c, like the left and right boundaries are not equal, then change one of them. So count it all plus 1. Yeah, and then we'll move on to the next and see if, yeah, like if left is equal to right, then we'll move on to the next until the left boundary and right boundary meets. I will say, I will not say meet because this is yeah, there's like a minus 1 or plus 1 thing, but yeah, and if it is not equal, then we will have to add the count. So so for this, I'll say if L equals R, then there is no, yeah, there's nothing in the in like it is an empty string, so we will return 0. And then if we'll return palindrome, so we will check if as L equals as R minus 1, if they are equal, and if equal, then DFS I think I'll have it will be easier, like count is 0, and if both of them are equal, then we will move on to the next. If they're not equal, then count will be DFS, palindrome count with left plus 1, right minus 1 plus 1. Yeah, because we had to change one character. Else it is count will be the rest. see. Oh. Index out of range. Index out of range. SL is 0. This can be 0. So J, like I will be 0 to n minus 1. N minus 1, 0. N minus 1, yeah. I think this is fine. This one I should add 1. Yeah, I should minus. Or this shouldn't be equal. Equal or like larger. Oh, again, we cannot use this as bullshit.